Something tells me this is going to be like a really elaborate show and tell. I feel like this is Ned's Declassified, where he had the weird pyramid thing and he submitted the same project to like 3 different classes and they're like, oh no, you can't do that. This video is entirely for the information class, but I'm explaining another project through it. Sort of like project inception. Not really, I don't know what I'm talking about. I'm going to be working on my analog conversion project while I talk to you about converting sound into electrical energy, even though I'm in the art school. I'm going to do the most basic explanation possible. Try to follow along. Energy conversion is necessary when you're talking about making video, so I can talk to you through the internet. Having the internet work, it makes your computer run, it makes cars go, it basically makes the modern world go around. This is a microcontroller. It's called an Arduino Uno. It's like the most basic startup inventor microcontroller that you can get. It's mainly for kids to tinker around. The microcontroller gets the program from my computer, and depending on what the program says, the microcontroller can do all sorts of neat things. The microcontroller works by having an input and an output. Inputs can be anything from mechanical energy, light energy, heat. They have a bunch of sophisticated sensors nowadays that even kids can pick these up for pocket change. So what happens to a sound wave? Because sound is strictly mechanical energy, at least to the Arduino, this microphone isn't picking up like tone, it isn't picking up, it can't tell the difference between my voice or the knock of a table. And actually, a knock of a table is better than my voice because my voice is sending mechanical energy through air, which, by the way, air sucks at transmitting sound. If we lived underwater and we could talk, we would communicate so much better. It would be much clearer, and it could travel longer distances. Actually, sound travels faster in water because liquid particles are closer together than air. In my project, a sound wave gets picked up by this. It's a sound sensor, aka a microphone. And the microphone has a component in it, the diaphragm. It's a thin membrane that is sensitive to the mechanical energy that sound produces. So every time I produce a sound wave, it moves the diaphragm and like vibrates. The diaphragm is key because what the diaphragm does is takes the mechanical energy and sends it to all these other components on the board, and those components can interpret the vibrations and turn it into electrical energy. Electricity travels the best in metal because metal carries electrons well. And what happens is that when the microphone picks up this mechanical energy, it converts it into electrical energy. And electrical energy is basically a bunch of electrons going down here through these wires into this microcontroller. After the energy is collected into the microcontroller hears that as an input and has to transfer that into data. And a microcontroller, like your computer, like your cell phone, like a lot of other electrical gadgets, can only read in binary. Actually, my English professor explained this to me in a really weird way, but I sort of got it. Maybe it'll help you guys. Binary is a set of 0 and 1s, which a 0 open means off and 1 means closed or on, because if you'll remember in 8th grade science class, a closed circuit can run electricity through it, where an open circuit doesn't allow electron flow. Take your fingers, basically imagine that down is 1 and up is 0. So, I don't know if I'm doing that right. Left to right? I think it's right to left. Binary goes right to left. Okay, so let's say we have 8 bytes. That means we have 8 different placeholders. In the first placeholder, I have 0, and in all the other ones, I have 0 right now because they're all up. The second I put one finger down, that reads as a 1. So now I have 1, 0, 0, 0, 0, 0, 0, 0. That reads as a 1. Go back up, this is 0. So what happens here? Here it's 0, 1, 0, 0, 0, 0, 0, 0. Since it's in the second placeholder, that means it's 2 to the first power. So this reads as a 2. 2 to the second power is 4. 2 to the third power is 8, 16, 32, 64, and the final one, which I believe is 128. So in an 8-bit, binary can hold up to 128 separate numbers, using only zeros and ones. 0, 1, 2, 3, 4. We're going to do it this way. 1, 2, 3, 4, 5, 6, 7, 8. See how that works? Now they're all zeros except in the fourth placeholder, and 2 to the third is 8. So we keep going. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I have faith that you guys got it. Microcontroller needs binary in order to make sense of what I'm trying to tell it to do. Loud sound will produce a larger number, which in binary will be like 1, 1, 1 as opposed to 0, 0, 0. Binary is a set of zeros and ones, on or off, signals that a computer can interpret, and then through a series of rules that I give it, it converts it back into electrical energy, and I'm using that electrical energy to either produce light energy or back into mechanical energy. An LED light works by taking the electrical energy and running it through a thin wire, and the wire heats up and produces light. The motor requires electrical energy, and it also has magnets in there, so the electricity running in a circle can push the magnet. Because electrons have negative charge, and magnets have a positive and a negative charge. So what happens with a motor is that the electrons that are going around in a cycle are like running through a copper wire probably, or some sort of metal wire, can push a magnet and sort of mimic this spinning motion. And that basically sums up my understanding of energy conversion in a microcontroller.